Hello everybody, and welcome to this episode of the YoungWonks podcast. Today we're going to be talking about how you would build an automatic mister for pets, especially pets outdoors in the summertime. This is a project that I actually did in order to keep my chickens cool in the summer, and I'll be talking about how you do it and some of the engineering considerations involved. So, the first thing is, I should remind you all that youngwonks.com/podcast is where you can go to ask questions. That's not very visible, is it? youngwonks.com/podcast. There we go. Now, to reiterate, what we're going to build is some kind of system that connects up to a mister, the kinds of things that spray a fine mist of water, and allows you to switch it on and off when the temperature is high enough automatically so that it can keep your pets cool. I have one of these set up in the run for my chickens because they live outside and Pleasanton gets very hot in the summer. So, let me just check if we have any questions to start out. Remember, youngwonks.com/podcast for questions. If you don't understand anything, make sure to ask. Podcast. Alright, nothing yet. So let's get started. The first thing you have to understand here is the critical part of this is some way of controlling the flow of water, from a hose or some kind of water source at the side of your house outside, controlling the flow of water into the mister. Now, the cheapest and easiest way to get something that controls the flow of water is to buy sprinkler valves, because you can get these at any hardware store. So sprinkler valves, and you've almost certainly seen these somewhere even if you didn't know what they were, are these little, usually green plastic things that go in line with water. They have a water input and a water output, and then have two wires going to them, and those wires control whether the water flows or does not flow. So, generally, these would be connected up to a device like this. You've probably seen one of these in your garage. There are more and less advanced devices depending on how old they are. And you would note that these things would be wired up to power, but also they would be wired to all of the valves so they can control the sprinklers. And some of these are more or less intelligent. Some of them can switch it on and off with temperature or how much rainfall. Others just switch your sprinklers based on the schedule. But this is generally how they work. So, the first consideration we have to talk about is the electrical signals that we need to power and control sprinkler valves. So, the majority of sprinkler valves of this kind that you'll get are a solenoid inside, which is a fancy way of saying electromagnet. It's a coil of wire that creates a magnetic field. And the coil of wire, exerts a force to open or close the valve, essentially. These usually actually have a mechanism by which, even if the thing is not powered, the pressure of the water causes the valve to close. But yeah. Now, what we need to understand, I guess, about these things is that, first of all, they do not, or should not, rather, be run on DC. If you want a refresher, remember, DC is direct current. That's where the polarity of the voltage doesn't change. It's just, one wire is ground, one wire is 12 volts, or something like that. Now, AC is what these run on, alternating current, and that, the polarity changes. If you imagine a graph of time versus voltage, AC is going to look like a sinusoid, a sine wave. So, these things run on AC, I believe, because it stops them overheating. Anyways, what you have to know is that we're going to need 24 volts AC for these things. That is sometimes written as 24 VAC. And you need to be able to control that. Now, obviously, you can't get 24 volts AC out of the pins of your Raspberry Pi directly. And you also probably don't want a direct electrical path between the Raspberry Pi's pins and this thing, even if you could somehow amplify it enough to get 24 volts AC and make it AC. The reason being that this thing is an inductor. It's a solenoid. As we talked about last week in our episode about relays, if you have a coil of wire like the one in a solenoid, it produces something called an inductor, and inductors dislike any change in the current flowing through them. So if you have current flowing through this coil of wire and then you stop it, you'll get a huge, something called a back EMF, like a big voltage spike that can damage things connected to it. So it is important to separate them. So how do we separate them? You guessed it, same thing we did last week, relays. So if you recall last week, we looked at this device, Adafruit relay. Where's it gone? Not that. Here we go. Power relay module. Now, this thing allows you to use regular logic level DC signals from Raspberry Pi's GPIO pins to control 120 volts AC wall power. Now, generally, I think the way you want to do this is not actually to try putting the 24 volts AC you're trying to control through this thing. This thing you still want to have mains through because that's what it's designed for. Instead, you're actually going to plug in a 24 VAC power supply into this strip. And then that power supply will connect to your valve. So if we kind of block diagram this out here, we're going to have Raspberry Pi. And then we're going to have relay box with 4 outlets. And then we're going to have GPIO pin signals going here. One of them is going to be some GPIO pin, and one of them will, of course, be a ground pin. Gotta make sure you have common grounds, otherwise the signals do not work. There's no circuit. So, we will also then have plugged into one of these outlets. I know that doesn't really look like an outlet, but you know what I'm trying to draw. Plugged into one of these, we are going to have 24 VAC supply, and then the 24 VAC from that is going to go to the sprinkler valve. All right. So, let's just think first of all about different logic levels at different places here. So signals. The Raspberry Pi will also obviously have its own charger connected to power it. Now, the Raspberry Pi's got 3.3 volts coming out of the GPIOs down here, right? That's the voltage you get out of Raspberry Pi GPIOs. However, the relay box allows that 3.3 volt signal to switch a much larger amount of power. In this case, it's actually switching the mains power coming out of the relay box. Remember that the relay box... Sorry, I didn't make this clear. The relay box is going to be plugged into the wall. Just through that plug, which you can see over here. So, when the Raspberry Pi activates its GPIO pin, current flows out here and into the relay box and back here, which causes the relay box to activate, which then causes current to flow from here out through the supply, which turns it into 24 volts, and then into the valve. You notice here, because this is a relay, and because relays work not by amplifying the input signal, but rather by using the input signal to actually open or close a contact, there is no electrical path between any of the AC stuff and the Pi. This isolation here, that's good. That's what a relay is for. It stops any kind of back EMF or other issues from the supply or from the mains damaging the Pi. Here we go. When you make a wall outlet, you'd make 2 I-shaped things and 1 O. Yeah, I know. I can't draw. Okay, this is an art class. Hi, Oliver. How's it like being an intern? Hopefully Raise Hand Cast will finish soon. Yeah, I hope so too, man. It's pretty good. Is that Neil? I think it's Neil. Okay, anyways. Now, I think both of these are Neil. He's the only one who asks questions with proper punctuation. Okay, so we need to look at how you would actually control one of these things. First of all, one thing I haven't covered yet. Where on earth are we even getting this 24 VAC supply? As you can see, sprinkler valve power supply. You can also get these at just any random hardware store. Here's one on Amazon. Okay, apparently it's not Neil. Okay. Yeah, so you can get these 24-volt supplies. If you look at the output, you'll notice they don't actually supply very much current. It turns out you don't need a lot of current to switch these things on and off. Certainly more current than you can get out of the Pi, though, so you do need to do the whole thing with the relay and the supply. And this is the thing you'd be plugging into your relay box. As you can see, there's just a plus and minus output that you're going to connect directly to the valve. And then you would actually just switch this entire thing on and off using the relay. So, how do we do this? First of all, you are going to have to work out what's going on here. You're going to have to, cut these and solder them to the wires on the valve. I recommend that we do not put the power supply outdoors, because that involves high voltage mains power, so we can't have it outdoors in case there's like water and it shorts between these, then draws lots of current. So instead, what we should do is put the supply indoors and then the valve outdoors. Indoors here, outdoors here. And that way, the only power that's outside is just the 24 volts AC, which is not nearly as dangerous. So these wires are actually going to be quite long. In my setup, I used a speaker wire just because it was relatively thick, but you actually don't need a lot of current, so the wires don't have to be that thick. You just need to make sure that everything is waterproof. Obviously, put shrink wrap on things. I think I also added dielectric grease to stop things from corroding. But yeah, try to get stuff waterproof. If you can, you might even want to have some kind of cover, basically an umbrella over this valve so that, rain doesn't get on it. And that would help us actually control the valve. Now, questions. What is VAC? Volts AC. Why not use a microcontroller for this instead, like a Pico or Arduino? Because I want this to be internet controlled if necessary. Neither of those things without external components can access the internet directly. VAC is volts AC, volts being the units and AC being the alternating current. Now, the next thing that we need to talk about is something we talked about last week, but I want to go over again, which is using hysteresis in order to make sure you don't wear out your relay. So let's talk about what on earth that means in engineering terms. So, we want a system that essentially does this. If temperature is too hot, turn sprinkler valve on. If temperature is not too hot, turn sprinkler valve off. This is a deceptively simple thing, but it's actually kind of tricky, and here is the reason. And again, we have talked about this before, but it bears repeating. Suppose that you have a graph of time versus temperature, So this would be in like degrees Celsius or whatever, and this would be in seconds or minutes. It doesn't really matter. Now, assume that the threshold for too hot is here. I.e., if this is above it, it's too hot. If it's below it, it's not too hot. All right. So, what... Oh, and also we're going to have a graph of the signal to the valve. That's going to also have time on the x, but here it's going to be voltage. And it's either going to be a 0 volts, i.e. off, or 24 volts AC, which is on. Now imagine that the temperature, it's here, it's here, it's here, it's below, it's blah, 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 it's below. That's fine. The voltage is going to remain at 0. Now, suppose that this voltage, ignore the colors, I'm just making this red so that it's a bit more obvious. Now, suppose that this goes above, and it's above, and it's above, and it's above. Well, now it's too hot because it's above the too hot threshold, which means that this voltage will be switched on by our code, and it will stay high all the way up to here. Now, here's the problem. Suppose that the temperature is really close to here, and it's like doing this. Well, if it's crossing this a lot, the voltage is going to be switched on and off all the time. That's not good. Now remember, if it's significantly below, then the voltage will stay off, and that's fine. And if it's significantly above, the voltage will stay on, and that's fine. The issue comes if it's right at the boundary and it's bouncing around across that boundary, so the voltage wants to like flip between low and high a lot. Now this is bad for a few reasons. First of all, the valves don't work very well when you switch them on and off frequently, but more importantly, this is not good for a relay. If you recall from last week, a relay is a physical device with an actual physical switch that gets closed by a magnetic field. And that physical switch wears out with time, especially if you're pulsing it a lot. Also, if you pulse it a lot, it will never like properly close or open. You can't PWM these things. They're meant to be turned on and off on fairly slow timescales. If you want something you could PWM, first of all, you wouldn't use that with a solenoid like this usually. But second, you're going to need some kind of other driver other than a relay. Could you integrate with something other than a Raspberry Pi? Not saying I don't have one. Yeah, anything that you can get the logic signals out of. But get an Arduino IoT board and RPI PIC, which is also IoT board. Yeah, you could do that. Anything you can get 3.3 volt signals out of would work for like the initial controller stage here. Actually, also 5 volts would work. I believe that Adafruit's product is tolerant for, hang on, yes, 3 to 60 volts DC, the control signals. So, what we need to do instead of having a single threshold is have 2 thresholds. This emulates something in electronics called a Schmidt trigger and adds a concept called hysteresis, which means that little bits of noise like this don't affect it. There has to be a large swing for the output to change. Let's show you what that would look like. What your code is going to have, instead of a single threshold it checks temperature against, is it's going to have a high threshold and a low threshold. I'm going to call this one H and this one L. Remember, this is time, this is temperature, and this graph is time also and output voltage from the relay. So, let's draw this out. If you have a temperature that is above, this thing will go high. Here's the thing, if it drops down to here, bounces around all that, this remains high. The only time this will go low is when this drops all the way below the low threshold. Once it drops below the low threshold, then this goes low. And then even if it's bouncing around going above the low threshold, this remains low. It will only go back high if this goes all the way above the high threshold again. So as you can see here, the entire, all of this business and all of this business, all this bouncing around has been removed. This is just smoothly on or off. Now, in code, this is fairly simple. You're just going to say if temperature is greater than high, then turn it on. If it's less than low, turn it off. And then you're going to have to make sure that the gap between high and low is suitably large, that it's larger than the, I guess, jitter of your sensor. You know, if your temperature sensor is only accurate to like 5 degrees and it's bouncing around between 5 degrees and 10 degrees all the time, you better make sure this gap is pretty large, otherwise this isn't going to help you. The very common temperature sensors people use are this one. I forgot them. Here we go. The DS18B20. This communicates with a protocol called OneWire, and it's a pretty accurate sensor. You can buy them in a number of different formats. I recommend getting one in a waterproof, shielded package that you can connect to the Pi, because otherwise the weather is just going to destroy it over time. So, that's how you would do this. Maybe in a later week we'll actually talk about specifically how you talk to temperature sensors. But this is how you do the electronics and the making and the signals and the code for something that turns a mister on and off when it's too hot for your pets. You could add tolerance as well for the temperature, yes. Where could you get a mister and what is one? It's just like a thing that you run water through that has tiny holes so the water comes out as a mist. You connect them up to a hose. Here we go. Here's a relatively cheap one. I've seen them for less though. It's basically just a hose with these little brass holes, like valve thing, not valves, but like holes in it. And when you have pressurized water in the tube, then it comes out as a mist, which is really good for cooling things down. I didn't go over this that well, but as you can see, the input to one of these is just going to be a regular hose fitting. So you can actually screw it to the output of one of these sprinkler valves. And if you don't, if the connectors are wrong, any hardware store is going to give you the kinds of adapters you need to connect from a hose or the water from the wall to this thing to a mister. Oh yes, and Vishal would like to say that you may have seen misters before, like in grocery stores. Let's try to find a picture of that as well. Yeah, these things. You know, they have a little hole in pressurized water and they spray out water as a fine mist. They're actually not using it to keep the vegetables cool. They're using it to keep the vegetables wet so that they don't dry up. But it's all, and alive, but it's all the same kind of thing. Again, hardware stores tend to sell these, also probably pet supply stores, or you can get them online. Cost of this system really varies depending on what parts you use. Very, very often you're going to have a bunch of like old sprinkler valves lying around your garage because, at some point you changed out your sprinkler system. There are things that break a lot, so sometimes people change the parts. The 24 VAC power supply, I should point out, make sure you do not use a DC power supply. That can cause these things to overheat. Yeah. So thank you all for coming. Next week we'll be doing another project. You can also submit questions saying like anything you would like to see, any projects, because I haven't yet decided on next week's project. So ideas, something you want me to go through how you would build, we can definitely do that. Thank you all for coming.